Good morning, everybody. Can you listen to me? Please raise your hand, everybody. Yeah, first today, what I want to give you is everyone. See, I'm giving my email ID and also my WhatsApp number. What you do is in the WhatsApp, everybody listen carefully now. In the WhatsApp, what you do, you put a request that you are from so and so batch, like you are PM2 or PM3 or PM6 or whatever it is, flexible, GM or whatever it is. And I need your fee receipt, fee details. So you put the screenshot of whatever your registration is, including your fee details or your receipt photo, anything. And then I will share my complete PDF notes after verification with my database, because my database has complete list of students who took admission. So only for the genuine students who paid the complete fees and who are my students of ACE Engineering Academy from any branch, any batch, what I'm going to do is I will share my complete PDF notes. I will share extra material and textbook, which are a lot of solved examples, etc., which I wish to share with you. Then later, you can directly post doubts into that WhatsApp number. And also when you are doing my notes, wherever doubt is there, you please ask me. Okay. So first, everybody, this is my WhatsApp number 9000616124. Don't call, please. Please don't call. Only message. Okay. Only message. And that too, what you do, you give me message only, and that too, please put your fee details or your ID card, whatever it is, fee detail, receipt, ID card, etc., mentioning your name and batch, So in this WhatsApp number, if you put that request, I will immediately send you a lot of things. Okay, that is the first thing. Second, my mail ID, kv.aceacademy@gmail.com. Okay, kv.aceacademy@gmail.com. This is my official email ID for ACE. Okay, na? So one is, yes, everybody. One, this is my WhatsApp number. Put only message giving your fee details and fee receipts and your name and batch number. Okay, then I will share a lot of material with you. You see what good material I can share with you. Then my email ID is kv.aceacademy@gmail.com. Okay, na? So everyone make a note of this, please. I want to remove this slide because I cannot share this with the team here. So everyone note down. I want to remove this slide, please. Note down my WhatsApp number and my email ID. So after today's class is over, you please put the request giving your fee details, name and batch, because I need to check with my database, which is already there with me. And I will send you a lot of material, PDF notes, textbooks, solutions, etc., etc. Whatever you ask, also you put a request there. Sir, I need so and so material from so and so topic. Please send me. I will send you a lot of things. Okay, now? Okay. So everyone note down this, please. No video call, no video call. Why such questions you will ask? When I'm not lifting call, you are asking video call. What nonsense question here? That is why you never declare your name, I know. Okay. Okay, chalo, let us continue from where we started yesterday. Okay. Quick review with what we did here yesterday. Everyone, I want to see. Yes, we started something called two-port networks. Yes, everybody look here. So two-port networks is a mathematical modeling chapter. Okay, it consists of two pairs of terminal describing the network where the positive reference voltage polarity and reference current direction is shown. Then here, out of 4 parameters V1, V2, I1, I2, 2 of them are considered as dependent and other 2 as dependent. So out of 4, 2 are dependent. So total 6 types of parameters with which we can model them. But in our syllabus, this Z, Y, H, and ABCD are there because they have applications. But G and inverse ABCD are not there in our syllabus. Then the network inside the ports must consider of, yes, linear passive bilateral elements only. Okay, the network inside the ports must consist of linear passive bilateral elements. And network inside may also have energy storage elements, but their initial conditions must be 0. Now the network inside may also have dependent sources, but never an independent source. Okay, these are the rules. So you cannot model everything in two-port networks, sir. Okay, only such networks can be modeled. Then symmetry in two-port networks. Yes, and there are few two-port networks which are symmetrical, where the ratio of excitation to response at both the ports are independently equal with respect to such defined circuit conditions. Okay, with respect to such defined circuit conditions. Okay, so here V1 by I1 equal to V2 by I2, but condition I took is open circuit. But symmetry is also mirror image property with respect to ports. Okay, with respect to ports. Then reciprocity, which obeys reciprocity theorem, that is different. The ratio of response to excitation remains constant even if the positions of source and load are interchanged. So in reciprocity, excitation at one port, response at other port, that is different. Okay, but all passive networks are default reciprocal. Then we gave the definition of Z. Okay, Y, H, of course, G I wrote ABCD and inverse ABCD. But yes, but you remember now in ABCD parameters, the positive direction for current I2 is leaving this box because transmission. Transmission means this is the positive direction and I2 is positive. But if you still take as per the definition inside, then you put negative and do. Okay. If you take inside the box, put negative and do. Or if you are saying leaving the box, take positive and do. Okay. Either way, you will get same answer. Okay. Now that you remember. Okay. Then we started simple things. Okay. Applications I told. Then we started modeling some basic applications in two ports. First, T model impedance form Z parameters. Directly Z11 is 1 plus 2, 3, Z22 is 2 plus 3, 5, and Z12 equal to Z21, 2. Okay, and I checked it. Then here also passive bilateral network, but T model impedance form. So first I wrote impedance at any frequency, S domain. Okay, so this is a conclusion chapter, sir. Here we are neither doing for only DC or AC. It is for any signal at any frequency. So a Laplace domain, but I converted into T model impedance form, and this is the Z parameters at any frequency. Then dependent model. Yes, dependent model. This is also Z parameters. Okay, which is understood. Now this particular network is neither symmetrical nor reciprocal. Neither symmetrical nor reciprocal because Z11 is not equal to Z22 nor symmetrical, and moreover negative impedance Z12 not equal to Z21. So it is non-reciprocal but active. Why active? Because negative impedance came. Okay, so that is meaning it is neither symmetrical. So I will write a comment. Neither symmetrical nor reciprocal. So in bit I can ask it is like non-reciprocal, active, non-reciprocal, active network. Why it is active? Because negative impedance came. Okay, so let us continue from there. Okay, everybody, let us continue from there. Okay, I'm continuing from there, everybody. Now find Y parameters for, chalo, find Y parameters for, okay, this network I am asking here. One dash, two dash, 1 Siemens, 2 Siemens, 3 Siemens. Okay, 1 dash, 2 dash. Okay, 1 Siemens, 2 Siemens, and 3 Siemens. Find Y parameters for the network. Okay, now listen, sir. Again, there is a shortcut for pi model impedance form. So if the network is in pi model, all are admittance form. Let me correct it. Admittance form. Admittances. Now listen. See, whenever the network is in pi model, this is pi model and all are admittances in Siemens. Then there is a shortcut. Now the shortcut for Y parameters are, now listen carefully. This Y11, see, Y11 is 1 plus 2, 3 Siemens. Y22 is 2 plus 3, 5 Siemens. And Y12 equal to Y21 is minus 2 Siemens each, Okay, so Y11 is 1 plus 2, 3. Y22 is 2 plus 3, 5. Y12 equal to Y21 is minus 2 Siemens. Now here the condition for reciprocity is satisfying, sir, because Y12 equal to Y21 though they are negative but equal, though they are negative but equal, once they are equal, y1 to equal to y21, it is a reciprocal. Reciprocal means it is a passive network only. So here please remember, y12 equal to y21, the condition is by default satisfying that y12 equal to y21, so it is a default reciprocal network. So network is 100% passive. Yes, network is 100% passive. Okay na? Chalo, y12 equal to y21 and network is by default passive. That is the meaning, network is by default passive. Okay, that is what you have to understand, network is by default passive. Okay na? That is the meaning you have to see. Okay, that everyone should understand. Now let me check directly also. Let me check directly. Now if I want to check directly, okay, if I want to check directly, everybody, now you know the y parameters, that I1 equal to y11 v1 plus y12 v2 and I2 equal to y21 v1 plus y22 v2. Now what is the condition to find y11 and y21? The condition to find y11 and y21. Yes, the condition to find y1 and y21 is v2 should be 0. Okay, now v2 should be 0. Now if I apply here, everybody watch this. See, the moment I apply, see the same network I am taking like this first. Okay, this is 1 Siemens, 2 Siemens, 3 Siemens, 1, 1 dash, 2, 2 dash. Now here automatically this is v1 and this is I1. Okay, and now v2 should be 0. Listen, now v2 should be 0, but I2 exists. V2 should be 0 means short circuit port 2. V2 0 means short circuit port 2. See, V2 0 means short circuit port 2. That is why they are called short circuit admittance parameters. Now what are the changes? Because I shorted this terminal, this 3 Siemens will not work. There is a short circuit across this. There is no potential difference, so 3 Siemens cannot work. Then full I2 will flow here, full I2 will flow here, and here both I1 plus I2 will come. So now I am writing a KVL here and a KVL here. So first observation, because it is conductance, V is I by G. V is I1 plus I2 by 1. That is first equation. And second equation, if I write, see what second equation? I2 by 2. Okay, I2 by 2. This is the positive direction, na? I2 by 2 plus again I1 plus I2 by 1 equal to 0. So from that I can write I1 is minus 3 by 2 I2. This is the second equation. So first let us find y11. Y11 is I1 by V1 na? So V1 equal to I1 plus I2. But what is I2 from here? If you substitute 2 in 1, I2 from here is minus 2 by 3 I1. There is nothing but I1 by 3. So V1 is I1 by 3. So from that I can write y11 is I1 by V1. Yes, I can write y11 is I1 by V1. That is 3 Siemens. 3 Siemens, because you got V1 equal to I1 by 3. So y11 is I1 by V1 is 3 Siemens. So we got same answer na. Similarly, what about yes, y21 is I2 by V1. So let us substitute. Now V1 equal to I1 plus I2. But what is I1? Minus 3 by 2 I2 plus another I2. So that is nothing but minus I2 by 2. Minus I2 by 2. So y21 is I2 by V1 is minus 2 Siemens. Minus 2 Siemens. Okay, y21 is I2 by V1. That is minus 2 Siemens. Please understand, that is a pakka minus 2 Siemens. Okay. So one way we got y11 as 3 Siemens. Yes, y11 as 3 Siemens. The other way we got y21 as minus 2 Siemens. Okay, y21 as minus 2 Siemens. Okay, na? So we got both these things. Okay, chalo, that is how we got. Similarly, to find y22 and y12, the condition is v10. V10 means port 1 short. You will get it. Okay, chalo, now I'm asking the IES question. This also is given in IES. Find y parameters for. Yes, everybody find y parameters for. Okay, find y parameters. Chalo, quick, sir, everybody. Quick, I want you to write the answer immediately. I told the concept and shortcut. This is an exam question only. Find y parameters. Okay, now see here, answer. This is already in pi model, but I need admittance form. Chalo, what is the admittance form of this C? If I write this in admittance form, okay, now we are finding admittance for any signal at any frequency. So this is also Laplace network function model. Okay, na? Chalo, any signal at any frequency. Now, if I go in that regard for any signal at any frequency, Siemens, na sir, this is 1 by S Siemens. This is S Siemens, and this is also S Siemens. Okay, so any signal at any frequency. Okay, actually S ohms, but in admittance form 1 by S Siemens. Okay, so now clearly the admittance short circuit admittance matrix is, see, I told now y11 is this plus this, that is S plus 1 by S. Okay, that is S square plus 1 by S Siemens. This is also S plus 1 by S, S square plus 1 by S Siemens. This is minus 1 by S minus 1 by S Siemens. Okay, that is the meaning. Okay, that is the answer. Okay, so that is the answer here. You have to understand here. Okay, that is the answer. Okay, it's conductance in Siemens. Okay, so now I'm giving gate 2 marks question. Everybody, gate 2 marks question. Find, yes, find y parameters for. Okay, find y parameters for. Now quickly you have to do, sir. Yes, everybody, find y parameters for this network. Now this is an application coming from analog, which is a feedback amplifier. I will tell you what it is. Chalo, try something immediately. 1 minute. Find y parameters for the following network. Everybody write the answer immediately. Find y parameters for the following network. Find y parameters for the following network. Yes, I'm going with solution. Sir, here, this is a concept coming from analog, sir. Such networks are very famous in analog. They are feedback amplifiers. Why? V1 is becoming 4V1. See, V1 is becoming 4V1. It is an amplifier now. Plus, yes, V2 is taken as a feedback. V2 is voltage. Voltage is shunt parameter, but it is given as current here. So shunt series feedback we call. So it is a voltage feedback amplifier. Okay, feedback amplifier it is. Okay, na? Okay, such networks come in analog. But here first I want to find Y parameters. Here there is no shortcut. Now automatically what is the condition to find Y11 and Y21? The condition to find Y1 and Y21 is V2 should be 0. So if I modify that, everybody watch this. Yes, if I do that, first let me write the original network and then I will tell you. First let me write as it is. First let me write as it is. First let me write everything. This is V1, this is I1, this is V2, this is I2. 2 ohms, 1 ohm, that is plus and minus 4V1, 3V2. Okay. So now V2 should be 0. So what is the meaning of V2 0? Short circuit port 2. Okay, V2 0 short circuit port 2. If you short circuit port 2, this is 0. Okay, V2 0 short circuit port 2. So the moment I make V2 0, this dependent current source becomes 0. This 3V2 also becomes 0. Na? Yes, dependent current source 0 can be replaced by open circuit. Dependent current source 0 can be replaced by open circuit. Yes, dependent current source 0 can be replaced by open circuit. So now we get the answer. So write a KVL here and link equation here. So if you write a KVL, V1 is 2I1. So automatically Y11 is I1 by V1, that is half Siemens, that is the first thing. Then similarly, if I write the second equation, 1 into I2 is equal to minus 4V1. Yes or no? That implies Y21 is minus 4 Siemens. Yes, simple equations I wrote. Okay, na? Chalo, we got two parameters, sir. I got Y11 and Y21. Then what is the condition to find? Yes, what is the condition to find Y22 and Y12? Yes, the condition to find Y22 and Y12 is V10. Chalo, V10. Again, sir, first let me take the original network. Everybody watch this. First, let me take the original network as it is. This is 1 dash, 2 dash. Okay. This he gave how much? 2 Siemens, 3V2, 4V1, and 1 ohm. Okay. So now I need, okay, let me take all the things here. First V1, I1. First I'm taking the original network, sir. And this is V2 and I2. Now the condition is V1 should be 0. The condition is V1 0. So I'm shorting this port 1, V1 0. So if I short this port 1, V1 0, everybody watch this, V1 0. Yes, the moment I short this to make V1 0, this passive element also won't work. This passive element also won't work. Then V1 0, this dependent voltage source becomes 0. Now dependent voltage source becoming 0 can be replaced by short circuit. Dependent voltage source 0 short circuit. Previously dependent current source 0 open circuit. Here dependent voltage source 0 short circuit. So again, just a comparison equation in KVL. Yes, if I write, see, I1 is default 3V2. So from that, Y12 is 3 Siemens, And second equation, V2 is 1 into I2. So Y22 is I2 by V2, 1 Siemens. So from this, I can write the Y parameters are, okay, the Y parameters are, yes, that is half minus 4, okay, and that is 1 Siemens and 3 Siemens. Okay, half minus 4, 1 Siemens and 3 Siemens. Half minus 4, 1 Siemens and 3 Siemens. Okay, that is the meaning here. So these are the Y parameters of the network. Okay, these are the Y parameters of the network. Okay, so once we get these 5 parameters, now I'm asking this gate 1 mark question. Everybody should answer this gate 1 mark quickly. What is H21? I'm only asking H21 alone. And this was gate 2017 1 mark question for electrical. Simple fundamentals, sir. This is R ohms, R ohms, R ohms. Okay, na? Resistance in ohms, star connected. 1, 1 dash, 2, 2 dash. I need H21. Chalo, quick 1 minute. H21 I want. Yes, now see here, sir. I need only H21, H parameters. See, what are the, first of all, what are H parameters? In H parameters, input voltage, output current are dependent. Like that, you remember. In H parameters, input voltage and output current are dependent. Then automatically, input current and output voltage are independent. So H11 I1 plus H12 V2. This is H21 I1 plus H22 V2. Okay. So now from this, what is H21 clearly? H21 is I2 by I1 when V2 is 0. So this is called as V20 means short circuit port 2. V20 means short circuit. Short circuit forward current gain, because I2 by I1 is called current gain, current ratio, and output by input is forward ratio. So short circuit forward current gain we call. So we call this as short circuit forward current gain. Forward current gain. Such things are important in analog, sir. For so many of your transistor circuits, op amp circuits, short circuit forward current gain we call. Chalo, now sir, in that regard, chalo, I need I2 by 1 when V2 0. I am substituting here. I make V2 0. Chalo, V2 0 means short circuit port 2. Then this is however V1, this is I1, and this is V2, and positive direction for I2 here in H is this only. Now KCL, if you apply here, this is I1, this is I2, so this become I1 plus I2. Then happily I will write a KVL. Chalo, if you write a KVL, yes, if you write a KVL, okay, what is that? I will get R I2, okay, plus R into I1 plus I2 is 0. Okay, RI2 plus R into I1 plus I2 is 0. So if you remove this R, okay, then I1 is 2I2. So from that, H21 is I2 by I1, that is half. Half is the answer. No units here because ratio na current ratio, no units. So half is the answer. So now I am asking another important question. Find ABCD parameters. Find ABCD parameters for series impedance Z. Yes, Z ohms. Okay, 1 dash, 2 dash. This is our short line. Electrical people, these are our application in short transmission line or short length transmission line we call. Yes, in short line or short length transmission line, you know. Yes, in short line, what is that we know clearly? Yes, clearly in short line, one thing we know is that the shunt parameters are neglected, only series parameters are to be considered. Chalo, now here I want this ABCD. Now what are the actual parameters equations for ABCD? Their input current, input voltage and input current are dependent. Okay, are dependent. Okay, automatically this is AV2 plus BI2. See, I am taking plus for I2 means you know the positive direction. CV2 plus DI2. CV2 plus DI2. Okay, DI2. Okay, chalo, now first to find A and C. First to find A and C. What is the condition? I2 should be 0. Okay, now to find A and C, I2 should be 0. What is the meaning of I2 0? Now see, first I will take this is V1, this is V2. Of course, this is I1. Now positive direction for I2 is leaving this. Because in ABCD, current leaving is positive, but still I2 is 0. Yes or no, sir? I2 is 0. Now, when you open circuit port 2, because there is only one series element here, when I2 is 0 as current is not flowing, so indirectly I1 is forced to be 0. Na? I1 has to be 0 again. See, please understand, sir. Because I2 is 0, as the condition for A and C is I2 0, the moment I2 is 0, it is a series branch. Na? In series branch, if I2 is 0, I1 is also 0. Okay, if I2 is 0, I1 is also 0. Okay, I1 is also 0. Okay, na? I1 is also 0. That is the meaning. Please understand. I1 is also 0. Now, sir, chalo, first I will find A. What is A? V1 by V2. A is what? V1 by V2. Okay, if you observe A, that is V1 by V2, because there is no voltage across, this impedance, so what is V1 by V2 ratio? 1. V1 by V2 ratio is 1. Okay, na? V1 by V2 ratio is 1. Okay, na? Then, because there is no voltage drop, na, sir, V1 equal to V2. Okay, similarly, what is C? C is I1. C is nothing but I1 by V2. Okay, now the moment I2 is 0, I1 is also 0 now, because series branch. The moment I1 is 0, C is 0. This also we got. Then what about B and D? The condition for B and D, listen now. The condition for B and D is, everybody, the condition for B and D is V2 should be 0. V2 should be 0. That means short circuit port 2. So I'm taking the same thing now. Okay, this is Z ohms. Okay, in this case, this is however V1, this is I1. Here V20 means short this port 2, and this is however I2. This is however I2. Okay, so now what is D? Yes, what is D? D is I1 by I2. Okay, D is I1 by I2. But because it is a series branch and currents are equal, so ratio of I1 by I2 is 1. Because I1 equal to I2, series na, I1 equal to I2. Yes, I1 equal to I2, it is series. So ratio is 1. Ratio is 1. Okay, ratio is 1. Then what about B? V1 by I2. What about B? B is nothing but V1 by I2. V1 by I2. Now V1 is ZI2. V1 is ZI2. So V1 by I2 is Z. Z. Okay, V1 by 2 Z. So automatically now, yes, automatically now, this ABCD parameters are, ABCD parameters are 1, this is C, 1, 0, this is D, this is Z. So 1Z01, answer is what? 1Z01. Okay, 1Z01. Okay, that is the meaning. So here 1Z01. Okay, that is the answer that you have to understand. Okay, this is 1Z01. Okay, that is what, please understand, it is 1Z01. Okay, once you understand this, yes, once you understand this, now I'm just giving a note here. Chalo, giving a note. And even ABCD parameters. Listen now, ABCD parameters for the shunt admittance branch. Yes, everybody, ABCD parameters for the shunt admittance branch. If you observe, yes, shunt admittance branch. Y Siemens. The answer is, yes, the answer is 10Y1. 10Y1. Remember. See, for series impedance, final answer is 1Z01. Remember. And for shunt admittance, 10Y1. Okay, 10Y1. You can get the same way, but remember this important formula. Okay, so series impedance form, ABCD parameters are 1Z01. Shunt admittance form, ABCD parameters are 10Y1. So now I'm giving the gate question. Find ABCD parameters for ABCD parameters for, find ABCD parameters for. Okay, this is N1 is to N2 turns ratio. Okay, then this is given as V1, I1, this is V2, and this is I2. Chalo, I want everyone to calculate the ABCD parameters for this. Okay, now he himself gave these directions. Okay, chalo, quickly 1 minute ABCD parameters. Okay, now listen everybody. See, if you consider this transformer as a black box, yes, if you consider this transformer as a black box, yes, I can now model this as a two-port network in terms of ABCD is asking. Okay, now in ABCD, this I2 is positive direction, luckily, na? Yes, he himself gave I2 direction, like source load concept. In transformer, this is source side, left side. This is the load side because sync notation. So, and I2 leaving the box is clearly positive. Now, what are the equations we want? Because this is already positive, what are the equations we want? See, we want equations like V1 is AV2 plus VI2, yes or no? And I1 equal to CV2 plus DI2. Chalo, these are the equations I want. Yes, in fact, these are the equations I want. Yes or no? Yes, these are the equations I want. That is 100% true. Yes, these are the equations I want. So now in that regard, everybody, now in that regard, now in transformer, this is machine model or circuit model. This is clearly machine model. In circuit model, L1, L2, M will be given. Yes, in circuit model, L1, L2, M will be given. But here, this is not circuit model, this is machine model. But in machines, you know, in machine concept of transformer, we know K is called voltage transformation ratio, which is N2 by N1, which is V2 by V1, which is I1 by I2. Chalo, now if you compare, yes, now if you compare these two, everybody watch this. If you compare these two, I can write this V1 as, watch carefully, V1 as N1 by N2 of V2, N1 by N2 of V2. Okay, plus formality 0 I2 I'm writing. Formality 0 I2 I'm writing. Okay, formality 0 I2 I'm writing. Yes or no? Similarly, if I compare everybody, these two equations, okay, these two, okay, then what I can write about I1, see from here, I1 is N2 by N1 of I2. Yes, I1 is N2 by N1 of I2. Here formality 0 V2 I will write. Formality 0 V2 I will write. Now, if you compare, yes, if you compare this equation with this and this equation with this, see now they are in ABCD form now. They are clearly of ABCD form. Like V1 is AV2 plus BI2, I1 is CV2 plus DI2. So now automatically these ABCD parameters are, chalo, if you compare ABCD parameters are, this is N1 by N2, this is 0, 0, N2 by N1. Okay, N1 by N2, 0, 0, N2 by N1. Okay, now clearly AD minus BC is 1 na, so this ideal transformer is reciprocal. Yes, AD minus BC is 1, ideal transformer is reciprocal. Okay, yes, but remember I am writing a note. Yes, I am writing a note. Yes, here ideal transformer in machines is reciprocal. Ideal it is reciprocal, practical no, is reciprocal. Reciprocal since AD minus BC is equal to 1. That is what proof here. What is ADC here? AD, that is N1 N by N2 into N2 by N1. Okay, that is N1 by N2 into N2 by N1 minus 0 is 1. Yes, and moreover, this machine model, listen now, this machine model of transformer, has only ABCD parameters and H parameters. Okay, parameters. But this model does not have Z and Y parameters. Because there is no connection directly. So for this machine model, there is no Z and Y you can define. Okay, but you can define only, yes, ABCD and H. Z and Y you cannot define. But circuit model of transformer, circuit model of transformer has all parameters, okay, like Z, Y, H, and also ABCD you can define. Okay, what is circuit model? See, in circuit model you can convert into T na, depending upon mutually aiding or mutually opposing. Yes, here dot convention will be given. Yes, dot convention will be given. M will be given. Okay, and this is L1, L2. Now you can convert this into T. Okay, then you can take this as V1. This is I1. This is V2. Suppose if I take this as I2, accordingly you take in H, Z and Y, this is positive. Z, Y, H, this is positive, but in ABCD negative. But you can convert this into T model. Yes, T model, and you can find all. You can find all these four. Learn such things, sir. In exams, they can ask. See, in machine model, only we have A, B, C, D, and H. But this machine model does not have Z and Y. But in circuit model, we have all. How to convert into T model based on mutual aiding or opposing, and you can do. Okay, now T equivalent. That is important. Okay, now I am writing a note. Yes, very important note. Okay, I want everyone to concentrate from now onwards. Okay, so basic definition based problems are over. Basic introduction is over. So now we are coming to something important. Yes, everyone should listen now. Two-port networks. Okay, two-port networks allows us to model. Please understand this. Two-port networks allows us to model our complex. Yes, our complex practical networks. Our complex practical networks into okay simple mathematical okay subcircuit models such as T, pi, lattice, double T, bridge, ladder networks, etc. See, what is two-port network doing? It models our complex practical networks and systems into such simple mathematical models. Now, using such simplified mathematical equivalent models, okay, of original complex network, we can still determine the performance of original network, okay, in terms of these two-port parameters. Now, what is the best example? Best example is this, sir. Best example. Okay, modeling our transmission lines. In power systems. Okay, modeling our transmission line in power system as T or pi network. Okay, T on pi. Using what? Using ABCD parameters. Okay, na? Parameters. Okay, listen now. I will tell the meaning. So why we are learning this? If anyone asks in interview, why we are learning this two-port? What is the reason? This is the best answer you can give. Why we are learning this chapter? This is the best answer. See what I'm trying to say. Two-port networks allows us to model our complex practical networks into simple mathematical subcircuits, such as T, pi, lattice, double T, bridge tree, ladder, etc. But what is the advantage? Using such simplified mathematical equivalent models of the original complex network, we can still determine the performance of original network in terms of two ports. Like example, best examples are modeling our complex transmission line network into T and pi model using ABCD. From that, sir, voltage regulation, efficiency, power factor, all this we can calculate, sir. So, original transmission line network is very complex, but we can model that original network into T and pi model using ABCD parameters. Yes, using such simplified equivalents, we can still determine efficiency, power factor, regulation, all these things. Okay, na? There is a big advantage. There is a very, very big advantage. Okay, na? So now in that regard, everybody. Chalo, first point I'm giving. First point, T equivalent representation. T equivalent representation of a two-port reciprocal network in terms of Z parameters. Okay, T equivalent representation of a two-port reciprocal network. Okay, of a two-port reciprocal network in terms of Z parameters. Okay, that means what is the meaning? If original network is reciprocal, if original network is reciprocal, and we have, if original network is reciprocal and we have its Z parameters, then I can represent as T. So this is called T equivalent representation of a two-port reciprocal network in terms of Z parameters, where this is ZA, ZB, ZC. So original network may be very complex, but I can model that original network in terms of Z parameters as a T equivalent. With this simplified model also, we can find everything. Where this formulas you have to remember, sir. ZA equal to Z11 minus Z12. ZB equal to Z22 minus Z21. ZC is equal to Z12 is also equal to Z21. ZC equal to Z12, which is also equal to Z21. Okay, na? ZC equal to Z12, which is also equal to Z1, because it is reciprocal, na? Z12 equal to Z1. That is understood. Okay. So there is a meaning here. See, original network may be very complex. Yes, original network may be very complex, but I can still model. Yes, original network may be very complex, but I can still model. Yes, I can still model in terms of T model using Z parameters. Okay, there is a meaning there. You have to remember this, please. Then second formula, pi equivalent representation of a two-port reciprocal network in terms of y parameters. Pi equivalent representation of a two-port reciprocal network in terms of y parameters. Original network may be very, very complex. Yes, even though the original network is very complex, please understand, even though the original network is very complex, okay, but once it is reciprocal, please understand, but once it is reciprocal, yes, even though the original network is very complex, but once it is reciprocal, we can write its pi model. Like this is YA, this is YB, and this is YC. Okay, this YA is Y11 plus Y12, YB Y22 plus Y21, and YC is minus Y12 is also equal to minus Y21. Remember this. Okay. See, original network may be very complex, but once it is reciprocal, I can model that in terms of pi network using what parameters? Using Y. That is a reduction technique, sir. Like reduction techniques. Then third, lattice network. Yes, lattice network. We learned somewhere, Nasar Selo, lattice network. Now, this is a basic structure of lattice. Okay, this is a basic structure of lattice. We have such designs in electrical engineering, especially filters and attenuators. So we are learning this concept. This is ZA, ZB, ZC, ZD. Look at the position. Now, if ZA equal to ZD and also ZB equal to ZC, then it is symmetrical and balanced lattice. Then it is what? Symmetrical and balanced. Symmetrical and balanced lattice. But if ZA not equal to ZD or ZB not equal to ZC, then this is asymmetrical and unbalanced lattice. Asymmetrical and unbalanced lattice. Okay, this is asymmetrical and unbalanced lattice. Asymmetrical and unbalanced lattice. Okay, that is symmetrical and balanced. This is asymmetrical and unbalanced lattice. Okay, asymmetrical and unbalanced lattice. Now, how to represent them? Chalo. Representation of lattice network in terms of Z parameters. Of course, in terms of Z parameters, provided it is symmetrical and balanced only. Shortcut. Only if it is symmetrical and balanced, there is a shortcut. See, what is the condition for symmetry and balanced? ZA equal to ZD and ZB equal to ZD. Now, once you find that lattice network which is symmetrical and balanced, then there is a shortcut. But if it is asymmetrical or unbalanced, then you cannot do. You have to do node shifting and find by original definition. That will take time. But yes, if if there is such lattice combination in our network analysis where filters and attenuators are there, such complex network which is looking confusion can be easily represented by Z parameters. So representation of lattice network in terms of Z parameters, provided it is symmetrical and balanced. So now here Z11 equal to Z22 is ZB plus ZA by 2. Okay, na? Like Z11 equal to, that means it's Z parameters I'm calculating. That is from Z parameters I can say this Z11, yes, he gave, yes, this what is giving here, Z11 equal to Z22 for this lattice is ZB plus ZA by 2. So this ZB plus ZA by 2, I will get Z11 and Z22. Similarly for Z12 equal to Z21, okay, for Z11 2 equal to Z21, yes, this is ZB minus ZA by 2. So from this now I can write Z11 plus Z12 is ZB. Okay, you add this now, sir. Z11 plus Z12 is ZB. Z11 minus Z12 is ZA. ZA. Okay, remember. Okay, remember. Okay, you can represent this. Now see this gate question to understand these things. Okay, to understand such basic things, everyone look at this gate question. Everyone look at this gate question. Okay, now look at this first gate question here. The port currents of a two-port network are given by okay, the port currents of a two-port network are given by I1 equal to 7V1 minus 2V2 and I2 equal to minus 2V1 plus 5V2. Okay, please understand. So the port currents of a two-port network are I1 equal to 7V1 minus 2V2 and I2 equal to minus 2V1 plus 5V2. Then its equivalent pi model is dash. Equivalent pi model is dash. Then its equivalent pi model is dash. Okay, the port currents of a two-port network are given by, yes, I1 is 7V1 minus 2V2 and I2 is minus 2V1 plus 5V2. Then its equivalent pi model is dash. Okay, so now listen to the solution, sir. See, he gave this current equation. See, clearly these equations represent what? The equations represent Y only, na? The given equations represent what? Represent what? Represent Y parameters. Represent Y parameters only. Yes or no? That is short circuit admittance. I1 is Y11 V1. So Y matrix is what automatically? This Y11 is 7, Y12 is minus 2, Y21 is minus 2, and Y22 is 5 Siemens. Yes, clearly Y. But now observation. Since here Y12 equal to Y21, because minus 2 given na, yes, original network is reciprocal. Original network is reciprocal. So pi model possible. Pi model possible. Otherwise, no, answer is not possible. You should write. Now, what is this pi model? Yes, just now I give the formula, sir. Now, what is the pi model for this? The pi model for this is something like this. Okay, this is like YA, this is YB, and this top one is YC. Now, what is this YA? Chalo, what is this YA? We gave the formula just now. Na? YA is Y11. Yes, plus 512. Y11 plus 512. Chalo, Y11 plus 512. That is 7 minus 2, 5 Siemens. It is 5 Siemens. 5 Siemens. Then what is YB? Chalo, what is YB? YB is again Y22 plus Y21. Y22 plus Y21. 5 minus 2. That is 3 Siemens. That again is 3 Siemens. Okay, 3 Siemens. Then what about YC? Yes, what about YC? Yes, minus of Y12 equal to minus of Y2. Minus of Y12 minus of Y21 is nothing but 2 Siemens. This is nothing but 2 Siemens. 2 Siemens. 2 Siemens. Okay, these are the answers. Okay, so 5 Siemens, 3 Siemens, and 2 Siemens. Okay, these are the answers. Okay, na? These are the answers we get. Okay, that is about pi model admittance form. Okay, please observe. That is about pi model admittance form. Okay. So now I am giving another IES objective. Find Z parameters for. Okay. Question is find Z parameters for the following network. Chalo, find the Z parameters for the following network. Everybody, yes, find the Z parameters for the following network. Okay, he's asking this question. Find the Z parameters for the following network. Now, if you observe everybody, yes, if you observe carefully, yes. Now this is symmetrical and balanced lattice. Now solution I'm writing. Yes, this is symmetrical. Yes, symmetrical and balanced lattice . Once it is symmetrical and balanced lattice, yes, we know ZA equal to ZD and ZB equal to ZC. Directly we can find the Z parameters. Now for Z11 equal to Z22 is ZB plus ZA by 2. ZB plus ZA by 2. It is 2 ohms. And for Z12 equal to Z21 is ZB minus ZA. ZB minus ZA by 2. It is 1 ohm. So the Z parameters are, chalo, the Z parameters are what now? Yes, Z parameters are clearly this is 2112 ohms. That is the answer. That is the answer. Okay. So now I am writing a note, everybody. Now I am writing a note. Z parameters are inverse of Y parameters, and Y parameters are inverse of Z parameters. Similarly, H parameters are inverse of G parameters, and G parameters are inverse of H parameters. But T is inverse of transmission parameters are inverse transmission parameters, provided it is reciprocal. And similarly, inverse transmission parameters are inverse of transmission parameters, provided it is reciprocal network. That is a big condition required here. Now, this is valid only if network is reciprocal. Okay, but these are valid for any network. Please understand. Because of the current direction I2, these concepts will come. So Z and Y are invertible. Y and Z are invertible. H and G and H. ABCD and inverse ABCD are invertible only if the network is reciprocal. Okay, remember that thing. Now see what sort of bits are given here. Yes, everybody, what sort of bits are given? Please now listen here. Okay, so if I go there, yes, what sort of bits are given? Now in gate it was given find Y parameters for this network. This is 2 ohms, 1 dash, 2 dash. Chalo, find Y parameters for this network. Everybody. Now see, he's asking Y parameters. Everyone listens are very interesting. Actually, here answer not possible. And in gate option, answer is none. Why? See, first of all, it is in T model impedance form now. If I consider this as T model impedance form, this is like 0 ohms here, 0 ohms here. Because this is like a short circuit now. See, I can say this is a T model impedance form. And this wire is ideal wire, 0 ohms, 0 ohms. So automatically, what are the Z parameters for this T model impedance form? Z is easy. Like Z11 is 0 plus 2, 2. Z22 is also 0 plus 2, 2. And Z12 equal to Z21 is 2 ohms everywhere. Okay, these are the Z parameters. Yes or no? Yes, these are the Z parameters everywhere. These are the Z parameters everywhere. Yes or no? Yes, these are the Z parameters everywhere. Okay, na? Chalo. Now, once you know these are the Z parameters everywhere, now what is the determinant of Z? What is the determinant of Z? Is 0. So with determinant of Z is 0, it is a singular matrix. So they are not invertible. So Y does not exist. So Y parameters does not exist for this network. Does not exist. So option is none. In gate he gave interestingly to confuse you, and you should write not possible. None is the answer. Okay, answer is none. Okay, answer is none. None is the answer. In IES he asked like this. In IES he asked find. Okay. Yes, find Z parameters for. Okay, he asked like this. Okay, find y parameters, everyone. Now, what are Z parameters? Now, here also, sir, this is in pi model admittance form. Now, see if you observe everybody, this is like open circuit. Now, what is the admittance of open circuit? 0 Siemens. Here also, this is open circuit. Open circuit is like 0 Siemens because for open circuit, impedance is infinity, admittance is 0. Now, this is like pi model admittance form. Yes, for pi model admittance form, we know the Y parameter shortcut. So, for pi model admittance form, what is Y11 0 plus 5Y? Y22 is also 0 plus 5Y, and Y12 is Y1, Y21 is minus 5 each. Yes or no? Now, determinant of this Y matrix is what? Determinant of this Y matrix is what? That is Y square minus Y square 0. So, it is singular matrix, singular matrix. Where it is singular matrix, not invertible, not invertible. When it is not invertible, Z does not exist. Z does not exist. So, even in IS bit, answer is none. So, answer in IS bit is none. You see, such bits came to confuse you, sir. Okay? Yes. So, now we have two important topics. One, interconversion. See, listen carefully. Interconversion between, yes, two two-port networks. Two two-port networks. So, sometimes we need to convert Z into H, H into ABCD, ABCD into Y, etc. Depending upon the network parameter. So, interconversion. Now, to understand this, sir, I am giving a question, example question. Determine, yes, determine, everybody watch this. H parameters, determine H parameters in terms of Y parameters. Okay, determine H parameters in terms of Y parameters. Okay, everybody, please understand. Determine H parameters in terms of Y parameters. Okay, determine H parameters in terms of Y parameters. Okay, determine H parameters in terms of Y parameters. Okay, now, yes, determine H in terms of Y. Now, to understand interconversion, first I'm taking an example question, sir. Determine H. That means I need H11, H21, H22, and H12 in terms of Y. So, how to do it? Solution I'm writing. Watch this, sir. See, in exam you cannot remember all, sir, but understand how to do that. Now, first of all, we know the equations for Y parameters. Now, what are the equations for Y parameters? Here, I1 is Y11 V1 plus Y12 V2, and I2 is Y21 V1 plus Y22 V2. Chalo, we know that first Y. And similarly, we know what are H parameters also. Now, what are the equations for H parameters? Input voltage, output current are dependent on H11 I1 plus H12 V2. This is H21 I1 plus H22 V2. Okay, this also we know. Okay, now, chalo. Now, first, everybody, what is the condition? Now, see, to find H in terms of I, everybody, to find H in terms of Y, yes, to find H in terms of Y, substitute the condition of H into Y. Like, for example, what is the condition to find H11 and H21? The condition to find H11 and H21 is, what is the condition? The condition to find H11 and H21 is V2 should be 0. V2 should be 0. So, substitute this condition here. Now, make V2 equal to 0 here. You will get the answer. If you make V2 equal to 0, this part is 0 now. So, you'll get the modified equations as, yes, I1 is Y11 V1 and V2 is 0, and I2 equal to Y21 V1. Chalo. Now, from these two equations, we can directly get. Now, what is H11? H11 is V1 by I1 when V2 0. Now, that V2 0 we already substituted here. V2 0 condition we already substituted here. Now, from this modified equation, I need V1 by I1. Chalo, V1 by I1. Watch this first equation, pink color. V1 by I1 is 1 by Y11. We got the first answer. Similarly, what is H21? H21 will be I2 by I1. Yes or no? H21 will be I2 by I1. Yes or no? Yes, I2 by I1. H21 will be I2 by, but I2 by 1 is a ratio of these two pink equations only. I2 by I1 is a ratio of these two equations. There is nothing but Y21 by Y11. Y21 by Y1. Y21 by Y1. Okay, na? Yes, both answers we got. Similarly, what is the condition to find H22 and H12? The condition to find H22 and H12, yes, is I10. the condition to find H22 and H12 is I10. Okay, I10. Now let us modify the same equation. If I modify this I1 equal to 0, everybody, if I modify this I1 equal to 0, yes, if I modify this I1 equal to 0, the modified equations will be, yes, what are the modified now? See, first of all, Y11 V1 equal to minus Y12 V2, because here I10 na sir, Y11 V1 is minus Y12 V2, but second equation is unaltered. Second equation is same. Second equation I am not disturbing. Chalo. Second equation is same. Chalo, now from these two, let us find the remaining. Now what I want first, let me find this H22. What is H22 from the definition? H22 is I2 by V1. I2 by V1 when I1 is 0. I2 by, sorry, H22 na, sir, let me correct it. See, H22 is I2 by V2 when I1 is 0. Now I10 we already modified here. Yes or no? When I1 is 0, we already modified here. Now from that I want I2 V2 ratio. Listen sir, I2 V2 ratio. But if I want I2 V2 ratio, let us first substitute V1 here. So this I2 equal to, okay, I'm writing here, this I2 equal to, okay, I2 equal to Y21 V1. But what is V1? V1 from this first equation will be minus Y12 by Y11 of V2. Okay, minus Y12 by Y11 of V2. And this part is same, that is Y22 V2. So I modified the main equations, sir. See, I10 I substituted in the main equation. This is the modified. Now solve them. What I want here from this I2 by V2 ratio. I2 by V2 ratio means I should substitute V1. But what is V1? Minus Y12 by Y11 of V2. Now if you substitute here, this I2 will be, now this is like AD minus BC, delta Y. Okay, this AD minus BC will be delta Y by Y11 of V2. Okay, delta Y by Y11 of V2. So from that I can write this H22 will be what? I2 by V2 delta Y by Y11. This is the third. And finally I need what? Finally I also need a H12. But what is H12? V1 by V2 when I1 is 0. V1 by V2 when I1 is 0. Yes or no? V1 by V2. But from this first equation here in the pink equation, the third equation, yes, here you see V1 by V2 directly is minus Y12 by Y11. Yes, minus Y12 by Y11. Okay, minus Y12 by Y11. So now I can say the H parameters are, yes, this is 1 by Y11, 1 by Y11. Okay, Y21 by Y11, Y21 by Y11. Okay, this is minus Y12 by Y11. This is minus Y12 by Y11. And this is delta Y by Y11. Delta Y by Y11. This is how I can convert H parameters in terms of Y parameters. Okay, see what I did, everybody. I substituted the condition what we get in H to Y and I modified that. Okay, now see here. Now I will give gate question to understand. Chalo, gate question, sir. Now this is what you can understand. Okay, that is why in exam, whatever you ask, you can do in 1 minute. So this gate question is find, yes, find, okay, Z12 and Z21, yes, in terms of ABCD parameters. Yes, everybody find this question. Okay, find Z12 and Z21 in terms of ABCD parameters. Okay, find Z12 and Z21 in terms of ABCD parameters. Okay, now listen to this, sir. So I want Z12, Z21 in terms of ABCD na. Okay, chalo. Now first we know, yes, we know what is the meaning of Z12. Solution I'm writing, sir. Z12 is nothing but V1 by I2. Yes, V1 by I2 when I1 is 0. There is a condition, sir. And what is Z21? Z21 is V2 by I1 when I2 equal to 0. Okay, V2 by I1 when I2 equal to 0. Okay, first of all, Z12 is V1 by I2 when I1 is 0, and Z21 is V2 by I1 when I2 is 0. Okay, na? Okay, Z12 is V1 by I2 when I1 is 0, and Z21 is V2 by I1 when I2 is 0. Okay, now sir, but what about ABCD? But remember, in Z parameters, what is the positive direction for current I1, I2 entering the box? but in ABCD, positive direction is leaving the box. In Z parameters, positive direction is entering the box. In ABCD parameters, positive direction I2 is leaving the box. Now we cannot take one entering, one leaving. Let us take all entering because Z parameters are already defined. Let us take all entering the box. But if you take all entering, ABCD I2 will be negative. Now the modified ABCD will be, that is input voltage is AV2 minus BI2 and I1 is CV2 minus DI2. What is the meaning of minus I2? Because it is entering the box. It is entering the box. Please understand. It is entering the box. Okay. It is entering the box. Okay. Please understand everybody what I am trying to say. Yes, it is entering the box here. Okay. So that is the meaning. Z12 and Z21 in terms of ABCD. But in Z parameters, the positive direction of I2 will be entering the box. But in ABCD, the positive direction is leaving the box. You cannot take one leaving and entering. So I took all entering, but I2 entering in ABCD is negative. That is why I leave. So now let us substitute this condition here. Okay, first let us substitute condition here. Now first if I take I1 0, if I take I1 0, yes, what are the modified equations? These two modified equations will be what now? Yes, V1 is AV2 minus BI2, that is same, but here CV2 is DI2. Now from that I need V1 by I2 ratio, V1 by I2. So if I want V1 by I2, everybody, I want Z12 na, that is V1 by I2 ratio I want. Okay. Now if I want this V1 by I2 ratio, let us substitute V2 here. So this modified equation will be this V1 equal to AV2. But what is V2? V2 is nothing but, yes, D by C of I2, okay, minus BI2. So clearly this V1 is AD minus BC. See here now, you observe, this is now AD minus BC, that is delta T by C of I2. So automatically this Z12 will be V1 by 2, delta T by C. But what is the meaning of delta T? Determinant of transmission matrix. That is AD minus BC by C. That is the answer. And now another bit he asked, what is Z21? In Z21, what is the condition? I2 should be 0. Yes or no, everybody? In Z21, the condition is I2 should be 0. Chalo, if I2 is 0, the modified equations of this are B1 is AV2 and I1 is CV2. That's it. Now from this, what I want? Z21 I want. But what is Z21? V2 by I1 when I2 is 0. But clearly V2 by I1, you see here, sir, V2 by I1 is 1 by C. 1 by C. So the final answers are, see, this is, yes, this is Z12 is delta T by C. Okay, this is delta C. What is the meaning of delta C? AD minus BC. And finally, yes, this Z21 is 1 by C. Z21 is 1 by C. Okay, now Z21 is 1 by C. That is the answer. Okay, that you have to remember. Okay, now like that, lot of bits we will do to get more clarity. Okay. Now the second part is interconnection between two-port networks. Interconnection between two-port networks. Interconnection between two-port networks. In that, first series connection or series connection. Series connection or series connection. What does it mean? This is network A. This is network B. This is network A, network B series connection. Na? Yes. Is going inside, coming outside, going inside, coming outside. So this is called series connection of port 1. Because in series, see, series elements is different, series network is different. In series elements, current should be equal. Na? Now port A is in series when current I1 is flowing even in the port 1 of network B. Because currents are equal in the ports. So this connection is called series connection. So your voltages will divide, but current is same. Same current will go and come out here. Similarly, series connection of port 2. What is the meaning of series connection of port 2? Yes, series connection of port 2. I2 will go here, come out here, and again go here and come out here. So if you observe, this is I2 entering, again entering I2, and again coming out I2. And this is V2. This is V2. Okay. Now in series connection, the Z parameters can be added. In series connection, the Z parameters can be added. The Z parameters of total network is Z parameters of network A plus Z parameters of network. Okay, Z parameters of network A and Z parameters of network. Okay, in series connection of two-port networks, the Z parameters of network A plus Z parameters of network B is total Z parameters. Okay, na? Yes, Z parameters of network A plus Z parameters of network B. Okay, na? Then parallel network or parallel connection I call. Okay, parallel connection. Now, when can you say networks are parallel? When voltages are equal. Okay, let us say this is network A and network B. Network A and network B. Okay, network A and network B I'm talking. Now port voltages must be same. So this is V1 and same V1 also will come here. This is also V1. And this is V2, same voltage will come here, V2. This is V1 and this is I1. This is V2 and this is I2. Okay, this is V2, I2. Now here, voltages are same, but currents are different. So here Y parameters can be added. So Y parameters of total network is Y parameters of network A plus Y parameters of network B. Okay, here Z parameters can be added, here Y parameters can be added. Okay, parallel network or parallel network. Okay, parallel network or parallel network. Okay, now then I can say cascade connection or chain connection or tandem connection. Okay, cascade or chain, where the output of first network is equal to the input to the next network. See, this is network A, where the output of this is given to input to network B. This is called cascade. Don't misunderstand, this is series. Series elements is different. This is series connection. Okay, but this is called cascade. No, this is overall V1, I1, and this is overall V2 and I2. So this is called cascade, but not series, please don't misunderstand. Now here, the ABCD parameters can be multiplied. That means total ABCD parameters of the network system is ABCD parameters of network A into ABCD parameters of network B. Here we have to multiply, remember, multiply. So here in series network, Z parameters can be added. In parallel connection, Y parameters can be added. But in cascade connection, the ABCD parameters should be multiplied. Should be what? Multiplied. That is very, very interesting. It should be multiplied. Okay, now that is different. So now, sir, I'm going with lot of gate questions. Now see this. If Z parameters of network N is 1 ohm, 2 ohm, 3 ohm, 4 ohms, then find total Z parameters of combined network. See the gate questions. So there is a network N. First he gave a network N. Okay, for this network N, these are the ABCD parameters. Now there is another network combined to it. Okay, like 1 ohm, 2 ohm, 3 ohm. Now he is asking the overall ABCD. So everybody watch this, please. See, the Z parameters of network N is given. For this box he gave. Now he's asking total Z parameters of the combined network. Okay, now everybody watch this question. I'm going with solution now. Everybody watch this question. Everybody watch this question. So now if you observe carefully, see, I can say this network, passive network T model, and this network N are in series. Why they are in series? Because current is going here and coming here. Current is coming out and going here. So both are in series. Yes or no? Yes, please observe everyone. Everyone, please observe. Everyone, please observe. Everyone, please observe. So the currents are equal. So this is series connection. That means this network and this network are series connection. So series connection means their Z parameters can be added. Now for network and Z parameters he gave. And for this network, what are the Z parameters? Now if you calculate the Z parameters for this network, yes, what are the Z parameters here? T network now 1 plus 2, 3, 2 plus 3, 5, and this is 2 and 2 ohms. Now automatically, so finally, Z total is the Z parameters of the given network N plus the Z parameters of the T network, Now if you add these two, see this is 1 plus 3. See the corresponding Z11 and Z11 here. 1 plus 3, 4. That is 4. And then this is 2 plus 2. This is also 4. 4, and this is 2 plus 3, this is 5, this is 5, and finally this is 4 plus 5, 9. This is the answer. This is the answer. Okay, na? That is the answer. Okay, now I'm going to another yes, IAS objective. Find y parameters for this network. Find y parameters for the network. Okay, find y parameters for the network. Everybody. Chalo, find y parameters for the network. Now I need the y parameters. Sir, these two are double T networks now. See, if I observe, if I give voltage V1 here, this T network 2 to 2 ohms and this T2 network at port 1 same voltage. But current I1 will divide now. So that means they are parallel. They are parallel. Similarly, here, suppose I give voltage V2, the voltage for two T networks at port 2 is same, but the current will divide. So this is also parallel. So parallel networks. So y parameters can be added. Chalo, first, if I take the first T, yes, if you take the first T, this is like 1 ohm, 1 ohm, and 1 ohm. See, first of all, Z parameters of A is what? Z parameters of A is 2, 1, 1, 2. From that, what is Y parameters of A? Inverse of Z. Yes or no? Inverse of Z. So if you take inverse of Z, directly this will become, this is 4 minus 1, 3 na. So this is 2 by 3 minus 1 by 3 minus 1 by 3 and 2 by 3. You know the inverse of 2 by 2 matrix na, sir, like that. Then secondary network. If I take the secondary network, all are 2 ohms now. This is 2 ohms, 2 ohms, 2 ohms. See, normal way, if you do reduction and find it is not possible, sir. It will take hell of a time. Now for this, what is Z of B? Chalo, Z of B is directly what? Yes, this is 4, 2, 2, 4. Then from that, what is Y parameters of network B? That is inverse of Z parameters. Now if you do that here also, yes, here determinant is 16 minus 4, 12. So 4 by 12, 1 by 3, minus 1 by 6, minus 1 by 6, and 1 by 3. Now I can say Y total is Y parameters of network A plus Y parameters of network. Now that if you do 2 by 3 plus 1 by 3, 1 Siemens, 2 by 3 plus 1 by 3, 1 Siemens, that is minus 1 by 2 and minus 1 by 2 Siemens. Okay, that is the answer we get. Okay. So now this is a gate bit. Find total y parameters for, okay, find total y parameters for this bridged T network. This is called bridged T. Then application to filter. This is a bridged T. Okay. See, previous network is called, this is called double T. This is called double T. Now this is called bridged T. So find y parameters. Again, sir, everyone observe this. See, if you observe again this network, okay, and this network are parallel to each other. Why? Suppose I give some voltage V1. This yellow color network and pink color network with respect to reference will get same voltage, but current will divide. Similarly, here also, if I give some voltage V2, this yellow color network at port 2 and pink color network at port 2 will get same voltage, but current will divide. So again, they are parallel, parallel. Parallel, parallel means y parameters can be added. Parallel, parallel means y parameters can be added. Now, sir, first for this T network, yes, for this T network, we already know, sir, yes, this is 1 ohm, 1 ohm, and 1 ohm. You know already Z. We already did this, na, sir. Z is directly how much? 2, 1, 1, 2. Then automatically y of this is inverse of Z. Yes, inverse of Z. We already know this. This is nothing but 2 by 3 minus 1 by 3 minus 1 by 3, 2 by 3. That is y. But this is interesting. Now this only capacitor is there. Only capacitor is there, 1 farad. Now we know pi model admittance form. There is a shortcut, na? Pi model admittance form. So first of all, what is the impedance 1 by S? Admittance is S Siemens. And this is open circuit and this is open circuit. What is the admittance of open circuit? 0 Siemens, 0 Siemens. Now I can say the y parameters of this network B is, now this is pi model admittance form. Y11 is S plus 0 S, Y22 is S plus 0 S, and Y12 is Y21 is minus S, minus S. Okay. Now I can say this Y total is just Y parameters of network A plus Y parameters of network B. So if you observe, this is S plus 2 by 3. Okay. Yes, this is nothing but S plus 2 by 3. This is also S plus 2 by 3. Okay. Minus of S plus 1 by 3. And this is minus of S plus 1 by 3. We are adding them, sir. See, this matrix and this matrix we are adding. This is S. Okay. So this is S plus 2 by 3 minus of S plus 1 by 3 minus of S plus 1 by 3 S plus 2 by 3. Okay. That is the meaning. Okay. That's the meaning. Now I'm coming to another important question. Yes, gate question again. Find transmission matrix or ABCD matrix for the following network. Okay, find the transmission matrix for the following network. This is Z1 ohms and this is Z2 ohms. 1, 1 dash, 2, 2 dash. Okay, everybody, try to solve this. Find the Z parameters for this. Now see here, I need the total ABCD. But if you observe, sir, this series impedance Z1 network and this shunt impedance, of course, he gave impedance, are in cascade. Now, these both are in cascade because the output of this network is the input to the next case. These two are cascaded. These two are cascaded. So their ABCD parameters can be multiplied. Now for the first part, yes, for the first part, the ABCD parameters is series impedance is how much? 1Z01, 1Z01, because it is series impedance, na? But here Z is Z1. Now this is impedance. What is the admittance of this 1 by Z2 Siemens? Na? This is actually given is impedance. So for this admittance is 1 by Z2. Now for this also, what is the Z? What is the ABCD parameters of the shunt admittance? 10 Y1, 10 Y1, na? 10 Y is 1 by Z2. Now I can take this total AB, ABCD parameters of network A into ABCD parameters of network B. You have to multiply them, sir. So multiply these two. Chalo, multiply these two. Chalo, if you multiply, this is 1 into 1, okay, plus 1 plus Z1 by Z2, and this is however 1 into 1, and that is Z1, okay, na? Yes or no? This is 1 into 0 plus 1 into Z1. Now, if you multiply these two again, 0 into 1 and 1 into 1 by Z2, and finally this is 0 into 0, 1 into 1, this is 1. So the final answer is, yes, the final answer is 1 plus Z1 by Z2 is A total, okay, and Z1 is B, 1 by Z2 is C, and 1 is D. So this is the final answer. Because both are cascaded, you have to multiply them. That is the meaning, sir. Both are cascaded. Now this is a gate question given for EEE. Okay, find total input impedance. Find total input impedance of the network. Okay, if you find total input impedance of the network, everybody watch this. He gave like this. This is A, this is B, C, and D. Okay, A is 4, B is 5, C is 3, D is 4. Okay, and I want a total input impedance of this network. And this network is terminated by 2 ohms. This, however, 1 dash, 2 dash. And I want this, yes, I want this impedance. So total input impedance of the network. Now everyone here, see, here is not asking like short circuit impedance or open circuit impedance. It's just asking impedance. It's just asking impedance. Please understand the meaning here. It's just asking impedance, and it is a terminated two-port network. There is nothing here. You are not taking anything out here. So you cannot take this 2 ohms as a separate network. It is a terminated element only, not network. If suppose there is some connection here, then it is a network I can take. But this 2 ohms is a terminated element only. And ABCD is given. Now he's asking total input impedance. Now, if I first model this network in terms of ABCD, now you know in terms of ABCD, this is V1 I1 and this is V2, and the positive direction of I2 is this only now. Positive direction of I2 is this one. And this is V2, this is the positive direction of I2. Okay. Now, first you write in terms of ABCD, what are these? V1 is AV2 plus BI2. I1 is CV2 plus DI2. Okay. V1 is AV2 plus BI2. I1 is CV2 plus DI2. Yes or no? Yes, this is what is observed here. Yes or no? This is what is observed here. Okay. Now, but according to Ohm's law, what is set input? Simply V1 by I1. Simply V1 by 1. But V1 by 1 is the ratio of these two equations. V1 by 1 is the ratio of these two equations. That means 4V2 plus 5I2 by 3V2 plus 4I2. That equation ratio. But if you observe again here, what is the Ohm's law here? V2 is 2I2. That is the Ohm's law. V2 is 2I2. Now, if you observe here, if you substitute here, V2 is 2I2. So that is 8I2 plus 5I2. Because I am taking V2 as 2I2. 2 4s are 8. 8I2 plus 5I2. But again here, 6I2 plus 4I2. So that ratio will be 13 by 10 ohms. 13 by 10 ohms. 13 by 10 ohms. 13 by 10 ohms. Okay, that is the answer. Okay, 13 by 10 notes. By 10 notes. Okay, na? That is the answer. Okay. So, yes, sir. Now, yes, everybody, we did everything here. Okay. Any doubts, please ask, because 10 o'clock you are having what? Everybody, 10 o'clock you are having digital. So I'm closing everything here. Now, everybody listen, first listen. See, I gave you my email ID and phone number. All of you today or tomorrow, take 2 days time. Put put your request as well as your details of admission. Please understand, I need your details of admission, like the screenshot of your ID card or receipt. Only then I will respond. And don't call me new numbers, I never lift. And any material, any book, anything you want, I will immediately send you, sir. 100% I will send you. Don't worry, I will 100% send you. Okay. What all extra, etc. And I will arrange a doubt session. There I will teach some extra topics if necessary. Okay, don't worry. So that doubt session may not be immediately, because Sheshu told me, the schedule manager, now tight schedule is going on. Maybe it may be even in December also. Don't worry. But by that time, read my subject and be ready. In December also, worst case January also I can take. Before exam, confidence and clearing your doubts is also okay. But Sheshu told the schedules are very tight because so many things have to be completed for you. So that is why he may not disturb now. Maybe in December I will get doubt session. But when I give doubt session for all the Triple E students, okay, come there. Okay. Chalo, now ask doubts, sir, for today's session. Anyone ask doubts for today's session? Imtiaz, what is your doubt?
Good morning, sir.
Tell me, Imtiaz.
Sir, in today's third question, sir.
Tell me.
Sir, can we do as the voltage dependent current source with the help of that circuit?
Voltage dependent current source. What you want to do?
From that Y11, Y22.
I will find out. Wait.
Third question.
What is your doubt here? What is your doubt here? What is that?
In this, sir.
Voltage dependent current source. What do you want to do? You can convert into current source. Convert into voltage source in series. Yes or no?
Yes, sir. From that I convert as the Y11
yes. No problem. That part is okay. This part is okay. Nothing is disturbed now. You can do that.
From right side is source transformation. Can we use?
You can do. Even there also like voltage source in series, current source in parallel. Yes, you can do that. Doesn't matter. As long as you don't disturb anything, no problem. But if you get disturbed something about parameter, etc., then don't do it.
Okay, sir. Okay. Sir, one more, sir. Sir, with the help of option, can we find as symmetric and reciprocity?
Yes, absolutely true. Yes, in terms of the given option. That is why if you do IES bits first, there are so many IES bits we need not do fully. Just observe 1 or 2 and you can find that.
Okay, sir. That's all, sir.
Yes.
Thank you so much, sir.
Right. Anyone else doubt? Okay, see, whatever request you put your details of admissions, plus I will send you my soft copy of notes, plus textbooks, extra material, lot of solved examples, question bits, etc. So many bits I have got, sir. But sir, whatever is necessary for exam, do that first. So whatever I gave until now is perfect. Do that first. Okay, na? Okay, na, everybody? Chalo, any doubt you can ask me. Otherwise, everyone get ready. 10 o'clock you are having what? 10 o'clock digitally starting for you. Yes, everybody, 10 o'clock digitally starting. Anyone doubt? Put that request to my WhatsApp. Pandey, what is your doubt?
Sir,
Pandey? What Pandey?
Sir, I have doubt in the next question, sir. H21.
H21. Tell me, Pandey, what is your doubt?
Sir, मेरा तो minus आ रहा है, sir. Minus half आ रहा है.
I think minus half ही सही रहेगा. Everybody, yes, see here. See, everybody here I wrote wrong. See. Yes, everybody please correct this. Let me correct. At least notes will be coming correct. Yes, I think आप सही हो. देखो इधर I1 will become minus 2I2. Yes or no?
Yes, sir.
Then H21 will be I2 by I1, which is minus half. Please correct it. Correction I will write here. Correction. Yes, you are correct. Minus half is correct, sir. Pandey, you told me correct. Thank you. Really, Pandey, correct. Thank you. Okay, right. And now, Bimilendu fine.
Yes, sir. My doubt is that Y parameter, when we are that by default it will be passive network.
Which one?
Reciprocal.
Reciprocal is passive, right? Yes.
Okay. Here, sir, all networks should not be, means from the parameter only we can define that it will be reciprocal or not. Otherwise, we reciprocating.
In the case of small independent passive networks, we can directly tell. Like here, all are passive only, na? You can tell. But here, suppose something like this come now, we cannot tell like that.
Sir, in a network analysis, if there is a complicated network, if I will check that in a problem, if I will check that this is a reciprocating network by response by excitation ratio.
Yes.
Then also we can directly
Tell. Yes, we can tell. We can tell.
Okay.
No,
that means
yeah,
V1 by
yeah.
I1. Okay.
Yes.
Thank
Okay. Right. So everybody put a mail, or you better put WhatsApp, whatever request, but put your admission details. Then I will send whatever you want. You ask me relevant to my subject, network theory, anything you ask, I will share my extra material in detail with you. Okay, na? So all the best. We will have doubt session. May not be immediately, but schedule manager told he will arrange some 4 hours doubt session, but not now. But whenever it is announced, please come, sir. In December also, let it be, because now schedules are very tight. He told that he cannot arrange in this month. Maybe next month I will pakka arrange. But meanwhile, learn everything and be ready. Okay, all the best. We will meet in the doubt session. Okay, and otherwise directly ask doubts in my WhatsApp also. No problem. Okay.